Today we're going to talk about finite geometric series. So a geometric series is the sum of the terms of a geometric sequence. So in order to find the sum of a finite geometric series, we use the formula below. Now what you need to understand is the formula on the left is the exact same as the formula on the right, except your terms are rearranged, but they are the same. So let's look at some examples. So example number 4 states that we need to find the sum of 3 plus 12 plus 48 plus 92, so on and so forth, up until we have 12 terms. So because this is a geometric series, we should automatically realize the following. Our u sub 1 is the first term, which is 3. Our common ratio is our next divided by our previous, and 12 divided by 3, 48 divided by 12, 192 divided by 48, all equals 4. So the common ratio is 4. So now that I have my information, and we also know that the number of terms is going to be equal to 12 as well, because it says up to 12 terms. So now that we knew all of that, then we can just substitute it into our formula. So I'm going to use the formula on the left. So S sub 12 is going to be equal to U1, which is 3, times 4 to the power of 12 minus 1 divided by 4 minus 1. And we can substitute that into the calculator exactly how it is written. So 3 times 4 to the power of 12 minus 1 divided by 4 minus 1. And we end up getting 16,777,215. So that is what we got. So number 5 is stating that it says find a formula for S sub n, which is the sum of the first n terms of the series 4 minus 2 plus 1 minus 1/2 plus everything going so on and so forth, following the pattern. So the first thing that we need to do is we need to find our common difference, or excuse me, our common ratio. So we already know that our U1, or our first term, is equal to 4. Our common ratio is going to be equal to our next, so that's going to be negative 2 divided by our previous of 4, which is negative 1/2. So that is our R there. And we want to just write the formula for it. So what you have to realize is when they just say write the formula for it, they just want us to substitute into it. So we're going to have S sub n is equal to U sub 1, which is 4, times the common ratio, which is a negative 1/2, times, or to the power of n, minus 1, divided by negative 1/2 minus 1. So of course we want to simplify it. So we're going to have 4 times negative 1/2 to the power of n minus 1 divided by negative 1/2 subtract 1 will be negative 3/2. And we already know that multiplying by a fraction is the same thing as, or dividing by a fraction is the same thing as multiplying by the reciprocal. So 4 divided by negative 3/2, or 4 multiplied by negative 2/3, it doesn't matter, you'll get the same answer, will end up being negative 8/3. So what we can do is we can say that this is going to be negative 8/3 times negative 1/2 to the power of n minus 1. That is going to be our sum equation. And then last but not least, number 6, it says a geometric sequence has a first term of 5/2. So that means that we know that our U1 is 5/2. And then it says it has a common ratio of 2. And it says the sum of the first n terms of the sequence is 637.5. And we need to find n. So we have to keep in mind that if we use the sum equation, we're going to have 637.5 is equal to, and then we can put U1, which is 5/2, times our common ratio, which is 2 to the power of n, minus 1 divided by 2 minus 1. So what we can do is we can put the left side in Y1, put the right side in Y2. So when we do that, it looks just like that. And then when we press graph, we're going to get our graph to look like this. So we only see one graph, and that graph is red, which means that that's the graph of Y2, which is the fraction. We don't have the graph of y is equal to 337.5. And because that's y equals that amount, we can change our window, and we can just change our y maximum to 650. And once we graph it, we can wait for the graph to pop up. Now I see that blue line. And we're going to wait until see where does that red line touch the blue line at. Okay, so we can see the intersection. So we press second trace, go to number 5, and we trace all the way over until we get as close to it as possible. Almost there. And then we press enter 3 times. And we see that here it says that n is equal to 8. So there were 8 terms in the sequence that caused the sum to be 637.5. If you have any questions, reach out to me and I am willing to help you. Have a great day.